This is question 1 of the Trilogy Foundation Chemistry paper from May 2018. There's an opportunity for you to pause and try the question before you review it. So here's 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, and finally 1.9, a total of 10 marks available. So let's work our way through and look at the answers. So the question is about structure and bonding, and we're showing part of the structure of calcium oxide. What type of bonding is present in calcium oxide? Well, the key thing to look for here is we've got charged particles. That's a -2 charge, that's a +2 charge. We're in a regular lattice. If we have a charged particle, we call that an ion. So we're going to see that this is ionic bonding, the attraction between the oppositely charged ions. On to 1.2, we have a particle of methane. What type of particle is shown in figure 2? Well, it's not an ion. There's no charge there. And it certainly isn't a lattice, because that's a giant structure. We'd see that in things like diamond and graphite, ionic substances, and even metallic substances. It is actually a molecule, a simple covalent molecule. We've got 4 covalent bonds, carbon bonding to 4 hydrogens. So, a molecule. 1.3, we've got the structure of C60. Which of these is the structure of C60? Is it diatomic? No. Diatomic is where atoms combine in pairs. There are certain elements that do that. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine. And you can actually see a pattern of those on the periodic table. But this is certainly not 2 atoms together. It's not giant ionic. We know it's not giant ionic because it's made up of non-metals, carbon. And an ionic compound is between a metal and a non-metal. And for the same reason, because we know carbon is a non-metal, it's not giant metallic. So by process of elimination, we can get to fullerene, but it is worth recognising it as a fullerene as well, the 3rd form of carbon after diamond and graphite. So we are looking for a fullerene. Moving on to 1.4, and we have got graphite shown, and we're asking what the bond labelled A is. Well, we've already spoken about this earlier. It's between 2 carbons. Carbons are non-metals, so that means it's not ionic, it's not metallic, and it's not a double bond, because a double bond would be represented with 2 sticks. That would be a double covalent bond, though. This is a covalent bond. It's a shared pair of electrons between 2 carbons. On to 1.5, and we've got the diagram there again to help you. Each carbon atom forms bonds with other carbons as shown. How many electrons does one carbon use to form one bond? Well, that takes you back to knowledge of covalent bonding. Carbon is in group 4, which means that it needs to gain 4 electrons. It does that by sharing 4 electrons, and it forms 4 covalent bonds. Now we can see here we've got 1, 2, 3 bonds to each carbon. In graphite, the 4th electron is actually delocalized. In this circumstance, because we know it's a single covalent bond, we know that we've got 1 carbon putting in 1 electron, the other carbon putting in the other electron, so each carbon atom, puts 1 electron in. 1.7, complete the sentence. Choose the answer from the box. Copper conducts electricity because of the movement of delocalized electrons. Really important that we use the correct terminology throughout this topic. On to 1.8, we've got a big diagram here. We've got sodium chloride solution, so it's aqueous. And we are electrolysing it. We know electricity is flowing because the bulb is lit. We've got the power supply. Complete the sentence. Figure 6 shows that sodium chloride conducts electricity when dissolved. The key word here is solution. Sodium chloride could be melted, could be molten, but it would be a very high temperature. So we're looking for dissolved on this one. And to finish off, we've got the diagram here of solid sodium chloride, and now we've got molten sodium chloride. And we're seeing that with solid sodium chloride, the filament bulb does not light up, electricity is not conducted, whereas with molten, the filament bulb does light up, it does conduct electricity. So, solid sodium chloride does not conduct electricity because in a solid ionic compound, the ions do vibrate, but they are in a fixed position. So that's what we're looking for. The ions cannot flow. The ions cannot carry charge through the structure. Whereas molten sodium chloride does conduct electricity because the ions are mobile. The ions can carry charge through the structure. And that takes us to the end of that question.